All right. So today is the webinar. My name is Stephen Roth, by the way, and I will be leading a webinar titled Ladybug Tools in Green Building XML, Open Source Tools for Building Analysis. And the agenda for this webinar is I will begin by providing an overview of Green Building XML and then conclude the webcast with some Q&A. Then I will pass it on to Chris Mackey of Ladybug Tools, who will be demoing some of the tools from Ladybug Tools and with an emphasis on gbXML. Then he's going to pass it to Michal Dengushak of Bierhauptwood Engineering in Berlin, Germany. And Michal will demo a new tool from Ladybug Tools called Spider, which is a web-based gbXML viewer. I'm pretty excited to show that off. And then Michal will pass it back to Chris to do a little bit more demo, and then we'll conclude with some Q&A. So just a couple of logistics. Please, if you have any questions, use the GoToWebinar applet where it says questions, and you can insert some questions there, and we will try to answer them either during the webinar or toward the end. And then all of you will be in mute only, so the only people that will be talking, obviously, are the presenters. And also, this webinar will be recorded, so I will be posting it on the gbXML website later this week, and then send out an e-newsletter with that link too. So let's get started. So what exactly is gbXML? So, you know, a lot of you, or many of you, may be new to the industry, and I give this overview during every webinar that we do. And so some of this may be a review for many of you, but for some of you it may not be, because there's lots of people entering this industry. It's an exciting industry. And these tools are exciting tools to use. These are open source, free tools, and gbXML is an integral part of it. So what is gbXML? Well, it's a schema. It's a language that is laser focused on allowing various BIM authoring tools and building analysis tools to share data with one another. So for example, you create a 3D model in Revit, and you want to export that information to an analysis tool, whether it's an energy analysis tool, HVAC load calcs, lighting analysis, whatever. Well, to get that information out of the BIM, you can save as gbXML, and then you can import it into these various analysis tools. So that's all it is it's a language. But it's a language that is laser focused on building analysis. And these are the types of analysis, the types of information that is stored in gbXML that allows for this type of analysis, including whole building energy analysis, water use, carbon emission, heating and load, HVAC load calcs, renewable energy, HVAC equipment sizing, and you can read the rest here. So, and there's more than just this list here. So the information in the gbXML file can be utilized in a wide variety of tools that perform this type of analysis. So what types of data can be stored in gbXML? Well, this is just a small list. In fact, there are over 500 elements, enumerations, and attributes in gbXML that can describe all aspects of the building. And here we have a couple of them, including 3D planar geometry, 2D rectangular geometry, space boundaries, thermal properties, life cycle cost analysis, HVAC equipment, glazing, energy power, efficiencies, water use, lighting controls, and schedules. And this is just a subset of some of the information that can be stored in the gbXML file. So why gbXML? I mean, what are the benefits of it? Well, think of the BIM as a database of all building information. And somehow we need to get that information out of the BIM and into the tools that allow energy modelers to create accurate building energy models, perform load calcs, lighting analysis, computational fluid dynamics, and much more. So gbXML actually helps facilitate this interoperability of transferring the information from the BIM to other software tools. So what are we doing now? Oh, actually, let me talk a little bit about the ownership and support of gbXML. So gbXML is an open source schema, as I mentioned. It's free, open to use. Anyone can use it for free, no licensing involved. All the information in the schema itself is available at gbxml.org and also on GitHub. And just do a search. We have a board of directors comprised of 11 BIM authoring and analysis software tool vendors. It's maintained by an industry consortium. We have over 40 software tools that support gbXML and literally more almost monthly now. So we have a lot of tools. You can look at the list of those tools on the gbxml.org website. We are currently funded by Autodesk and other partners. 6.1 is the latest version, and we've been around for 18 years. So we definitely have longevity in this industry. So what are we doing now? I'm not going to go into too much detail since I really want to get to the meat and potatoes of this webinar, and that's the demos. But what are we doing now? We're really working on validation because we want to make sure that BIM authoring tools are able to properly export valid gbXML. So over the past couple of years, we've actually created 3 levels of compliance, and you can see brief descriptions of those levels of compliance here. Level 1 is most basic. Is it valid XML and is it valid gbXML compared to the gbXML XSD? Level 2 is where we actually create simple geometric test cases. And one example of that is here, where we would say, hey, BIM authoring tool, can you export a window where there's a shading, an overhang that bisects it, and it needs to be represented as 2 separate windows. And then we compare it to a truth standard. And if the comparison matches, then you pass that specific test case. So that's what's called level 2. And then level 3 is what we're working on now with Georgia Tech and Autodesk. And level 3 actually tests for automation. And that's a whole nother topic that we'll probably do another webinar in 6 to 9 months on. All right, so let's get to the meat and potatoes of this webinar. And I'm going to pass this on to Chris Mackey of Ladybug Tools, and he's going to do a demo of Ladybug Tools with emphasis on gbXML. So let me pass it on to you, Chris.
All right, thank you, Stephen. Can you see my screen all right?
Yes.
We can.
Okay, thank you for the confirmation. All right, so let's dive in here. So I'm going to give a little bit of a presentation just to put ourselves in the context and explain what Ladybug Tools is before we dive into some full demos. I guess while we're waiting for this to load up, so the 3 of us from Ladybug Tools here, which include Theo, Michal, and myself, we are all developers for Ladybug Tools. And our mission statement as developers is that we want to make environmental design and knowledge and tools accessible to every person, project, and design process. This is our mission statement as creators and developers of Ladybug Tools. And we do that by sticking to a set of values that we have held dear for the 5 years or so that we've been working on this project that Ladybug Tools has been driving. And the first one is one that Stephen had mentioned in the beginning, which is that we are certainly committed to doing open source software. Everything that we produce is open source. The vast majority of it is under a GPL license, which those of you who are familiar with that means that the code that we create is forever open source. So anyone taking that code and putting it in another piece of software must also make it open source. And so we are committed to doing that. Another one of our core values is that we believe in validated engines. And instead of simply creating our own engines, we link a lot of the CAD design software and BIM software, as Stephen mentioned, to validated engines like Energy Plus for energy modeling and OpenStudio. We link to Radiance for daylight modeling. We link to OpenFOAM for airflow and CFD modeling. We link to LB&L Therm. So we're committed to connecting to these validated engines that more often than not are also open source and have been validated by a big consensus of experts. And then lastly, a critical value of ours is that we believe in having community-driven software. So many times we feel that the quality of software gets compromised because of the need to maybe, let's say, sell it or in order to try and turn a profit from that software. The software is not as good as it can be or as responsive to the needs of the industry. And so we believe in trying to drive our development by the needs of the industry and the community. And that is, I mean, again, aligned with our open source philosophy is the idea of linking out to these validated engines. And so as a result, I mean, we largely attribute the somewhat success that we've had so far with the tools of the last 5 years to these values. And since the time when we started this software, we've grown to become one of the most popular plugins for Rhino Grasshopper with 160,000 downloads. It's the third most popular Grasshopper plugin. We're starting to get some usership with Dynamo BIM. And we have 27 code contributions from various different members across our community. We have an active forum with over 2,500 discussions and many, many replies to those. So we attribute a lot of this to the values that we've been sticking to over the course of our development. So now, because I know a lot of the people on this call aren't necessarily familiar with Ladybug Tools, I just want to fill you in on what exactly the software is, what are the open source tools that fall under this umbrella of Ladybug Tools. And whereas, as the name might suggest, we started out as a single insect. We started out with just the Ladybug. We have since grown into a suite of insects, well, actually a suite of insects and one arachnid, if I'm getting technical here. And we have 5 separate tools right now, which are mostly meant to link different types of CAD interfaces with engines, or in the case of Spider, which is the one that we'll be talking about today, visualizing the output of those CAD interfaces and editing them. So just to run quickly down this list of insects that are part of Ladybug Tools, we'll start with the one that seems most obvious. That Ladybug itself is just a plugin that links Rhino, Grasshopper, and Revit Dynamo to weather file sources, and allows you to simply visualize that weather data, analyze it, and analyze your geometry in relation to it and estimate renewables. So it's largely a plugin just for dealing with weather data and visualizing, analyzing it. Honeybee takes on a bit more of a kind of node within a network structure. So the purpose of Honeybee is to connect Rhino, Grasshopper, and Revit Dynamo to several validated engines. So it connects to Radiance for daylight. It connects to OpenStudio for energy modeling. Well, OpenStudio, which then translates to Energy Plus as the engine under the hood that runs the energy modeling simulation. And it connects to LBNL Thermin Window, or I'm told I'm supposed to call it now Berkeley Lab Thermin Window, to do conductive heat flow modeling through detailed constructions. So that's where Honeybee sits, and we're going to be using this. In my demos today, I'm going to be using Honeybee a bit. But in addition to that, we also have Butterfly, which is meant specifically for CFD analysis. And so Butterfly connects Rhino, Grasshopper, Revit, and Revit Dynamo to OpenFoam, which is, at this point in time, it's really the only validated open source CFD engine. And from OpenFoam, we're able to do analyses like detailed thermal comfort, HVAC ventilation or mechanical ventilation modeling, natural ventilation modeling, and we can do both incompressible flow or wind-driven flow, as well as buoyancy or heat-driven flows with Butterfly. And sort of coming up to the 4th insect here, we have Dragonfly, which is admittedly still under development, but we have some of the modules available and exposed right now, which again links those CAD interfaces to several different databases of climate data, including some NOAA and NASA databases that have things like thermal satellite images. It's meant to warp EPWs for future weather, and this is one of the ones that are still under development. And the one that we do have a pretty solid hold of right now is warping weather files to account for urban heat island effects using an engine called the Urban Weather Generator, which is, again, an open source validated engine. So that's Dragonfly. And lastly, the insect that we're arguably going to spend the most time with today is Spider. And you'll notice what makes Spider unique in relation to the other insects is that it's not directly linking into Dynamo or Grasshopper, but is rather like meant to operate mostly out of your browser. And so from the browser, there are a number of capabilities now built into Spider, including the ability to look at sun path visualizations, do shadow studies within that, generate gbXML or edit gbXML, look at RAD files, and the critical one that we're going to be spending most of today that Michal is going to walk you through is gbXML viewing in the Aragog editor, which we've kind of named as a subset, a species of Spider. So that's a quick tour of all the insects within the Ladybug Tools suite. But before I sort of hand it off to Mikhail to do some demos with Spider, I just wanted to kind of highlight how all these plugins are linked together. So the first 4 insects that I showed you there are all plugging into the CAD interfaces of Rhino, Grasshopper, and Revit Dynamo. And they're plugins for those interfaces. And for this reason, they're pretty well linked to one another in a kind of web that we put here. And if I'm going to be totally honest with how we've been developing so far, Theo and Michal have been largely working on Spider somewhat independently of the plugins that are going directly into the CAD interface. And admittedly, we're kind of using 2 different languages here. So whereas the Grasshopper Dynamo plugins are written in Python, pretty much entirely written in Python, the web plugin is written in JavaScript and runs client-side within the browser. But saying this, though we've been developing these 2 somewhat independently, these 2 webs will eventually talk to each other. And we're starting to develop a lot of the infrastructure that will really bind these things very tightly together, including JSON schemas and to-from objects. But for the time being, arguably the strongest link that we have between these 2 webs is gbXML itself. And so that's exactly what we're going to demo for you today. We're going to start by having Mikhail show you and debug a gbXML using the Aragog editor in the web browser. And then we're going to pass it off. He's going to pass it to me, and I'll actually run some simulations with that gbXML using the web of the insects on this side. So with that, I'm going to pass this over to Michal so he can demonstrate some of the capabilities of the web browser. So let me see. So Michal, you should have the presentation baton.
Yeah, hello. Let me know if you can see my screen.
Yes, I can see it.
Okay, perfect. Thanks, Chris. What a treat we have today for the user. We're going to show this amazing workflow. Hi, everybody. I am Michał Dęgusiak. I live in Berlin, Germany, and currently working for Bureau Happold. I'm Senior Charter Building Services Engineer who recently transformed completely into digital design, trying to streamline workflow between Revit BIM, building physics, and MEP design. The missing part in my Ruby cube was always the free and open source tool to quickly view and fix gbXML models, especially from Revit. So as a project director for Aragog, I'm here to show you this kind of great tool, free and open source gbXML file viewer that can display files in the browser. And with me today is the Theo Armour, who is the project developer and maintainer. Hello, Theo.
Yes, hello, Michal. I'm here too. Yes, I have the great pleasure of coding this application that you're going to be seeing today. I am a former licensed architect, former program manager for AutoCAD at Autodesk, and I live in San Francisco. I've been coding with the 3JS JavaScript library since 2010, and my pleasure in life is coding for 3D environments. I want to thank Stephen Roth for creating this event and Chris Mackey for being an excellent Ladybug Tools founder and maintainer. So in this presentation, if you have any questions, I will try and answer them in the text chatted area. But in the meantime, thank you. And Michal, back to you.
Okay, great. Thank you very much, Theo. So Theo is an amazing guy. We know, spending almost twice a day, 8 p.m., 8 a.m. He's great support, and we're working very, very well as a team. So here I already show you this kind of 2 feature that you can load the models from your local files, or you can just link the models that are set up on the network. And here we're gonna just now load another model that we're trying to use for today for this demo. That we're gonna try to fix it and send it to Chris so he can show us what we can do this currently in Ladybug. As you can see, as an opening pop-up window for Aragog, we have this kind of page with the link to the YouTube video, and thanks to Michalina for supporting us and recording the video, and also this kind of latest released information. We can click anywhere just to close this window, and here we are. We have the model that can be open on any browser, but also it can be open in any tablet or iPhone. So we can actually hide left-hand side menu, right-hand side menu to have this kind of full screen view that we can just visualize models in different environments, regardless if it's in the comfortable place at your home or you are in the train or inside the meeting. We have this kind of top clicks here at the bottom where we can switch off the surfaces, edges, and bring everything back. And if you want to come back to original setup, you just click reset view and everything come back to the starting point. Here on left-hand side menu, we have this kind of main feature. We can go to the settings, and this is the place where we can control this kind of visual side. So we can change the materials to put random in case if you want to see what are the different surfaces made of for a particular space. So it's much easier to distinguish how many elements are contained within the space. We can check the funk material to allow better visualization for the shadow calculation. And we can change through the exposure type materials. In this case, if you want to assess if building, which parts are exposed, which parts are internal. The green one are exposed, red internal, and those are the shades. So we can see straight away, okay, something is to be able to needed some fixes for this model. I will come back to the original setup. We can also change to the wireframe, and we can control the opacity of our model. Here below, we can also change the background just to help control the views we like. And don't remember that if you like different color schemes, you could change them just to fit your mood a particular day, just to make sure you enjoy using the tool. We can switch off the axis, and we can switch on the ground just to see the shadows. One of the cool features is that we can explode the building, and we can also reset. And now I would like to show this kind of way how we could interact. At the moment, I'm doing all operation based on the whole building. However, when we click any surface, the right-hand side menu pops in, and then we can actually find out more details about a particular surface. So here we can see the surface ID is 13086. We can actually isolate this ID. We know this belongs to the roof, and this have this particular CAD object ID. We can also check which space is attached to this surface. So here we can see the space, and this space belongs to this story. So it's very, very cool and easy, quick way of investigating the models in the first place to see if it is designed, constructed as is per our intention. And as long as we have anything selected here, we can use the same toggles from left-hand side. And in this case, if I want to show normals, only the normals for this space will be presented. I can switch off the edges. So now we have very nice and clean view. And it's the same way I can now explode this particular space to better understand what's happening within this space. So we have full control, and we can really easily investigate any model. And we're working now also on this kind of section view, which is quite cool, because this allows us to see and investigate model from inside. So we can cut the section, and we can see if walls are aligned as we expect, and if generic setup is what we would like to see. Okay, so those were the standard settings, which I just presented. Now let's move to the reports. Reports, usually it means that we can see multiple data. It's almost like presenting tabular data in 3D. So we can actually check the surfaces. We can always, type the number, and we can see this as well. It's the same thing. We can show surfaces by type. So those are the gbXML types. So here we can see all the interior walls, interior floors, exterior walls, and so on. So it's quite powerful way of identifying if we don't have any wrong elements. Here we can see that we have some shade inside the building. Is now the question if this is correct or not. We're gonna come back to this stuff. You can always click all visible and everything stops. Here we can also check all the spaces, and we have this kind of generic details here. But one of the favorite, which I'm using on all my project, and this is where I always start, is to checking per story. Here we can really see all this kind of overview per level in our building. So it's quite powerful way of just checking if everything looks right and if we are happy with our model. Now let's check here. Those are amazing feature for all Revit user. As you, if you were using Revit, you know there is lots of problems with Revit when they export gbXML, because the models have to be quite perfect, and this is very quick way of checking how our gbXML were produced, and those are like grouped by family and type, so we can see if the U value that we apply is as expected by us and is compliant what we're trying to achieve. All this data we're gonna be able later on to change and fix. I will show this later. And at the bottom we have just catalog object ID. And below here is this kind of generic details about XML. And one of them is, for example, the campus location. We have here linked to Google Maps, so we can actually check where is the location of our building. In this case, is the Bristol, yeah, and maps it showed exactly in the correct place. Okay, so I presented here the feature of the reports. Now go to the most exciting and amazing stuff. So I'm drawing my models in Revit for already a few years. And I was always suffering for lots of issues that are coming from the Revit export. And here we were trying to tackle the most common problems. So those are the issues which we are listing at the moment. So let's try to discuss them and try to solve them while we talk. So let's start with the first one, duplicate adjacency. This is the common problem with Revit, where we have two duplicate surfaces with different data. So let's have a look at the first one. We can use the right-hand side menu, the surface bottom, to hide the surface. So if I click twice, I can actually hide the elements. And I can click it again, and we are back at the start. So if I click on the first surface, we know it is between those two spaces, which was 3354. And we know it is wrong because each internal surface should be connected to two different spaces. In this case, we have opposite. We have two surfaces that are connected only to one space. So all we have to do is quite easy. We have to just delete this one, 3354, and connect to the second one, 3354, and then click update. And now we're gonna do the same with the second one, 3307, and we're gonna apply this 3307. Okay, so here we fix the issues with duplicates. At the moment, there is this kind of internal memory, so it still remember the one we deleted, but as you see in a second, once we save it, this will disappear. The second problem we have in this model is the duplicates. So we have actually two exact the same surfaces in the same place with different data. So let's see what's the first one. The first one is exterior wall that belongs to the space. Okay, everything seems to be fine. It's exterior wall and everything seems to be fine. So I will hide the surface. And when we click on the second one, we can see it's shade and it's connected to the space. So, and doesn't have any data, which means this is not necessarily needed. I will just delete this one as well. And I will click issues again, and you see it automatically solved the last problem. And apart from this, we're also tracking the errors if catalog ID is missing. Here is just more for indication. Here we're just displaying the small surfaces, and we can actually toggle how small we would like to see or how big. And here we're just showing surfaces with closed vertex. And if surface type or opening type is invalid with gbXML schema. If you create your own gbXML, they will be also listed here. Okay, so I fixed all the issue. Now I'll try to save the changes. At the moment, I'll save them as a JSON file. So I save them to the file. I will reload again the fresh model. And now I will open and upload the changes to our model. Here we can see what we did. We just deleted 3 surfaces and updated to 1. Now if we click on any surface and save edit, this kind of final gbXML will be loaded. So this is saved, and I will load our latest file. And in this new file, hopefully we should not see anymore any errors. As you can see, all of them are fixed one, which is great. So we actually fix now gbXML, and hopefully we're gonna be able to send this to Chris so he can show what we can do with this. But before we do this, I also would like to show you 2 more things. First are the numbers. Number is our approach to quantifying the models and to seeing some kind of numbers and calculation that we run internally. So here we can actually display area per story, also area by surface type, and also orientation openings. We're tracking here the area whatever units it is gbXML written plus wall-wall ratio. So it's quite interesting way of displaying and seeing which orientation we have, so we can start to compare buildings and have more data and more use for our gbXML. Okay, so yes, and on the right hand side, I think I cover most of the stuff. So this is just for quantifying and seeing all the stuff. Yeah, so I think on this note, in the closing point, I would like to say that we can always load the large file. We even test up to 300 megabytes file, and I will be very happy. We save lots of time and hassle on many projects that people run on Revit. So I hope you're gonna try test this tool, and you're gonna give it a go. And please contribute through Ladybug Tools and put any your question on the GitHub forum. And thanks for all watching this webinar, and I hope to see you soon. And Chris, please, we save you the fixed gbXML, and I will be very keen now just to see what you can do next with this file.
Okay, thank you, Michal. I have, here we go. Thanks for passing the presentation baton. And hopefully you can all see my screen. So I have your gbXML on my machine right now, the clean gbXML file that you've got there. Before I just go in and straight open it and import it into Honeybee, I just wanted to give a little bit of context to exactly what we're doing here in relation to this web. So some of you may have noticed that the way that I drew these gbXML arrows connecting the viewer that Michal has been working into our web here is that it's connecting in through the OpenStudio route, which is this icon right here is signifying OpenStudio. And this is probably going to have more meaning to those of you who are familiar with Ladybug Tools, but I think it's important to highlight nevertheless, just to say how exactly we're dealing with gbXML right now. So 3 years ago, when we were starting to engage with gbXML with Honeybee, we knew that, well, we already had the graphic interface in Rhino Grasshopper, which is what we're going to use today to import that gbXML file. And we knew that we wanted to get into a gbXML format. We wanted to somehow take our geometry and get it to a gbXML place. And we knew we had Honeybee able to talk to Rhino Grasshopper and assign a bunch of properties for an energy model, which could be translated into a gbXML. And 3 years ago, the way that we were dealing with this is that we tried writing our own translator, which we called, well, we thought was clever. We called it Grizzly Bear because the GB is like the G in gbXML. And so we had built basically a translator to take all of that info in Honeybee and spit it out into gbXML. But as we were working with this more, we realized, one, I mean, it's a very, particularly with what Stephen was talking about in the beginning of having validated workflows for gbXML, when we're doing everything ourselves like this, it's hard to maintain it and keep it at the standard that we know it's validated. And perhaps most importantly, this was only a one-way street, that you can only take an energy model that you built with Honeybee and export it to gbXML. So the philosophy that we're using these days is that we've kind of deprecated our original Grizzly Bear workflow. And Honeybee today is using OpenStudio and the translators that are built within OpenStudio to go back and forth between gbXML. So it's now a two-way street because we're using OpenStudio. And more importantly, that OpenStudio, as an open source project, they've already built a very, very good gbXML translator back and forth. So why reinvent the wheel? They're also doing a great job maintaining it and stuff. So that's the big reason why we're using this right now. So all right, so now that I've kind of explained a little bit what's on the back end now, let's bring this XML file into Rhino Grasshopper here. So you see I've got my Rhino window up. I've got Grasshopper here, which many of you are probably familiar with, is a visual scripting interface that runs off of Rhino. For those of you who are seeing Grasshopper for the first time, the way that it works is you have a canvas and you have components. And components have inputs and outputs, and each component runs a specific type of calculation. And so you see with Honeybee, we have tons and tons. This whole menu up top here is just a list of different components. There's about 350 in total. So there's a lot of customization you can do by mixing and matching these components. But for now, we're just going to work with this one component that takes a file path to our gbXML, which you see is set right here to go to that sample gbXML that I've gotten from Michal. And it simply takes a little button here that tells you to import it. And you can filter for different zone names if you don't want to bring in the whole model. Since, as Michal said, some gbXMLs can get up to 300 megabytes. So you don't always want to import the whole model. But in this case, I'm going to take the entirety of the model that we've got here and import it. So I'm just going to double click this. And admittedly, this laptop computer I'm on is a little bit slower, so it's going to take some time to import this. But this is going through essentially what I just explained. It's converting the, oh, let me double click that again. So there we go. It's converting the XML to an OpenStudio model. And from OpenStudio, we're translating all those properties into HB zones or Honeybee zones. And you can see when it's finished that we have now imported all the zones, all the window geometry, the context surfaces, everything that was in that gbXML is now going over into Honeybee. And these sort of closed B-reps that are coming out of Honeybee zones right here are simulatable zones. So I can take these right now and plug these into an energy simulation to run an energy model, or a daylight simulation to run a daylight model. And by the end of this session, we will do those things. But right now, I just want to show you some of the capabilities of what we can do now that we have these Honeybee zones in here as editable Honeybee objects. So first, I'm going to just show you that not only has the geometry come in like this, but all the surface types and adjacencies have also come in. And so I have another component here that's made to take Honeybee zones and separate out those surfaces that are walls and windows, etc. So I'm going to connect up our Honeybee zones right there. And I'm going to turn the preview off here so we don't have multiple things displaying on one another. And I'll connect the shadings up to this one, just so we can see what exactly are these different surface types. And sure enough, you see that we have those window surfaces are coming in correctly. We even have interior windows coming in as well. And each of these, the roof surfaces are being interpreted correctly. The ground boundary conditions are being brought in correctly. So again, this is just to show you that all of that information is being brought in, and these are now simulatable zones, basically. But all right, now I said we'd go and try and edit the model a little bit now that we have things in Honeybee. And one of the simplest things that I can do, I mean, there's a lot that you can change and edit with these components up here. But I'm going to just use this one right here, which is meant to change the glazing ratio of a set of zones. So in this case, we can do this for the entire model. the entire set of honeybee zones here. And if I connect those up to the honeybee objects, and I connect up a glazing ratio that I want the building to have. So in this case, I mean, I'm going to use what, if you guys have worked in Grasshopper, you'll recognize the component I'm about to use here, but this is called a slider. And I'm going to bring one up here. The basic idea of a slider is that it can go from a certain value to another value, and you could slide through an entire space of options, of different parameters, basically. And so if I connect this up to glazing ratio, in theory, I should be able to use this to change the glazing ratio of the whole model. So that's not working right now because we need to set one other toggle button to run it right there. But before I do that, I'm just going to, because I want this to run relatively fast on my little laptop here, I'm going to tell it to not break up the windows into smaller surfaces like what you see in Michal's model here. And so it's only, in this case, it's only going to generate one window per exterior surface. So let me set this to true now. And you'll see this component will run after a few seconds, and it's overwriting all of the windows. And just to be sure about this, I'm going to turn the preview off here and connect up these new zones that are coming out of here. I'm going to connect that up to the visualization component that we had here. And sure enough, you can see now it has made the entire model at 90% glazing, or almost fully glazed. And again, this is going to be probably a little slow on my laptop here, but as I drag this slider, we should see that the glazing ratio will update over the entire model, over all of the 80 or so zones that are across this model. And so this is meant to show you, I mean, this type of workflow, as Michal said, like this model started, it originated in Revit, and changing the entire glazing ratio of a Revit model is something that's relatively difficult to automate. But because we've gone through this workflow, because Michal was able to create a clean gbXML using Spider, and because we were able to import it, we can now actually set up an entire simulatable model like this with a parametric glazing ratio pretty easily. And just to talk a little bit about the implications of what this type of workflow means, or like what are some of the things that we can do now that we have this capability, and that we have sliders like what you see on the image of my screen where we can change the glazing ratio, is that we can pick any number of parameters. Because we're in a visual scripting interface, it's particularly easy to change either geometric parameters of the simulation or a range of other parameters that we're interested in. So for example, this was one project that I was working on where we were interested in testing parameters like the window height of this facade, the sill height of this facade, the overhang depth and the overhang angle. And all of these types of things can be automated, can be parametricized, if you will, in Grasshopper, such that you can create a parametric model that creates all combinations of the facades between these four variables. And so after we'd kind of selected the criteria we're interested in studying, we could select a range of different outputs we're interested in, like, for example, glare. In this case, this is showing you months of the year on the x-axis, time of day on the y-axis, and the hours where you have direct sun through the facade that will cause people to pull the blinds down. We can look at things like useful daylight. And of course, as we're going to do right now, we can look at energy use and peak loads as well. And so once you have a parametric model like this set up, it's relatively straightforward to run through all the combinations of those within Grasshopper and record all those results, such that you can slide through that whole design space of options like what you see here and see the impact. As I raise the sill, the energy use goes down, the peak loads goes down, but I have little daylight. If I raise the ceiling height, the daylight gets better. So you can go through this whole sort of design space now with what started as a Revit model. And for those of you who aren't familiar with Design Explorer, this is another web interface that Mustafa, founder of Ladybug Tools, had built in order to say, out of all these options, show me just those that meet a certain EUI target, or that have below a certain threshold of hours of glare, and that still have a high amount of useful daylight. And from all those options over the entire design space, you can pick out those that make the most sense. So that's really what we're kind of talking about when we have this ability to parametrically edit entire models like this of what you see here. All right, so now, I mean, I've been saying this whole time that these are fully simulatable zones. So I figured I might as well go ahead and prove it. So we're going to take these set of edited honeybee zones and run them through OpenStudio Energy Plus using this component that I just yanked down here from the tab. And you'll see that this OpenStudio component takes honeybee zones as an input. So I'm going to connect up honeybee zones right there. You'll see you can also take context shading, which, as you see, we have in this model, right? So I'm going to take those shadings and connect those up to honeybee context. And then I need a few last parameters for the simulation, like a weather file. And I actually, because I don't want to run the simulation for the whole year, because this is a webinar with a limited amount of time, I have some parameters already ready to go over here for the simulation that should get it to run fast. Let me just create some room here. So among the things that I'm doing, I have a weather file for New York. I guess I probably should have picked Bristol. But now I know to check that within Michal's interface. But in this case, we'll just run it for New York right now. I'm only going to run it for 1 month of the year, so I'm just going to run it for December in order to keep the simulation time down. So I have some time to show you guys the results of this. And I'm going to make the solar distribution a little bit more simpler with these parameters right here. And that'll get it to run faster. And so now, if I just go and take another button, a Boolean button here, set it to true, and have it write out an OpenStudio model, it's going to take these edited honeybee zones that we've collected here, and it's going to write them into an OSM format. And perhaps more importantly for our purposes here is that it's going to write out this is the model object from OpenStudio. And this model object is what we can translate directly into an updated gbXML. So that's what I'm going to do right now. I'm going to grab our, let's see, it's OpenStudio to gbXML. And you'll see that this component takes the model as an input. It takes an XML file path that we want to write to. And actually, I have that file path I want to use in this other file here. So I'm just going to copy paste it. There we go. So we want to write the XML to this path. We'll just call it edited model for now for clarity. I'll connect that up there. And you'll see at this location on my machine where I want to write it to, there's no XML model yet. But if I now go and set a Boolean toggle to true and connect that up to export, you'll see it'll take the component a few seconds to run, but it's going to convert that OpenStudio model back into a gbXML format. And sure enough, here's our edited model gbXML file that has the glazing ratio that we edited back here that was all the way at 1%, or sorry, 10%. And in fact, you know what? To make this a bit more realistic, I mean, we usually don't do 10% glazing ratios. Let's do something closer to like a code baseline of 40%. And you'll see as I update here, it's going to rewrite out the OpenStudio model and re-export out an updated gbXML. That now looks like this instead of Michal's original model. All right. So in a second, I'm going to show you that this gbXML file actually is what I say it is, that it looks like this by importing in the editor. But for now, while I'm doing that, I want to actually run a simulation, the simulation I've set up here. So I'm going to connect that same Boolean toggle to make sure that after it writes out the OpenStudio model, that it runs it through Energy Plus. And then we'll go and take a look at some of the results that we get out of that. So while that's working right now, and actually I'm going to give it a few seconds to really show you that the simulation is running. You're going to see a command prompt pop up, and there we go. So this is now actually running that model through Energy Plus. And it does seem like that maybe all right, something was happening there, but I'll for now I wanted to take that edited gbXML and I'm going to bring that edited model right here, open it within the editor, and sure enough, you see that we now have a 40% glazing ratio building. So you can see it would be very easy to, let's say, set up a code baseline building as a result of this. So that gbXML model is what I had said it was, and let me just understand what let me see what happened here. That the simulation, it seems that okay, so it didn't quite bring in. I'm just going to try rerunning everything. It seems that the boundary conditions weren't coming over completely. So we'll just rerun this right now, and then hopefully all should be well. If not, I have the working version in right next to me. And maybe while we're waiting for that to run, I mean, you can check some of the properties of this edited gbXML, all the stuff that Michal had showed you previously. In terms of finding, clean surfaces and editing the model, all of that can be done from here. So again, as I said in the beginning, it's really meant to be this two-way street.
Hey, Chris, this is Stephen. So we're getting close to the end of the webinar, and I did want to allow a little bit of time for questions. We have a lot of.
All right. In that case, yeah, rather than running and waiting for the whole simulation to run, I'll show you that I've actually been able to run the model successfully here. So we have that same model. Yeah, I think this is better. And so in this case, Stephen, yeah, I'll only show you quickly what you can do with the results. So this is that original model. We have the edited model right here with 40% glazing ratio. And let me see, I'm going to turn the preview off here. And you see we bring in the energy model results. So in this case, we ran it for December. And so we have all the heating energy use for all the individual zones for each hour of the month. And so in this case, I'm going to actually color the zone geometry with the results of that energy simulation. So this is the floor normalized heating load that you see here in kilowatt hours per square meter. And you can see, kind of unsurprisingly, the highest heating load intensity is in these shallow zones that are on the north side of the building. And that these zones on the south side actually don't have nearly as high of a heating intensity, as do these ones that are in contact with the ground or in the center of the building. So again, you can see that these results make sense here. And then rather than running through building an entire daylight model, I've actually taken the same zones, or actually in this case, I've taken the original zones that we imported from Michal's model, and I've created a grid of test points on which I want to analyze daylight. So we have a full grid of test points here. And you see I've set up a sunny sky in December 21st, so on the solstice at noon. Actually, I'm sorry, it's not a sunny sky, it's a cloudy sky that I've set here. And I have run this through a daylight simulation using a number of CPUs. And we can now visualize these daylight results, these illuminance values for that sky, using the same gbXML geometry that Michal had taken from Revit and edited within the gbXML viewer. So hopefully, I mean, yeah, hopefully this gives you a sense at least of the workflows that are now possible now that we have these gbXML workflows. And as long as you have a clean gbXML, you can set these things up and run these things yourself. So with that, as you said, Stephen, I want to make sure we give some time to questions. So just to wrap up quickly, thank you again, everybody, for joining. Let's see, yeah, and let's open up the floor to questions and to the chat. Is there, Stephen, should I pass the presenter? Or I see you've got the presentership now. Thanks, Stephen.
Yeah, I'll do it. All right, everyone. Thank you so much. This is amazing. This is great stuff. I mean, I'm seeing a lot of this for the first time also. And you know what? It almost makes me think we need another webinar just to show. There's just so much to show in all these tools. So we may just do another webinar in a couple months. We got a ton of questions. So what I'm thinking, it's the end of the webinar technically. If if a number of you want to stick around for some of these questions, I'd say let's go for another 5 minutes. And then what we'll do is we have a record of all the questions. And what I'll do is I'm going to pass all these questions on to all the panelists. We'll answer them, we'll post them on the gbXML website, and then we'll send out an e-newsletter announcing where that web page is, so you can view answers to your questions. But let's do a couple now. Technically, it's the end of the webinar, but let's do another 5 minutes. And what I'm going to do is I'm going to read a question, and then any of the panelists who want to answer, who are able to answer the question, feel free to chime in. So I'll just start from the first valid question here. Can I do sensitivity analysis in uncertainty analysis with this tool. So I think, Chris, if you want to answer that one.
Yeah, I can definitely take that one. Thanks, Stephen. Yeah, so absolutely. I mean, because you're in a visual scripting interface with Grasshopper, it's very easy to parameterize almost any parts of the model that you're interested in studying. So yes, I mean, in fact, actually, I do have a screenshot up here of a sensitivity analysis I ran with some of the results. I don't know if it's possible, Stephen, if I could share my screen, but I mean, or we can just simply say that the answer is yes.
I'll pass it to you. I'll pass it to you.
All right, cool. Then I can show you some of this. So, for example, that's an exact study, that parametric study of the facade. This was a somewhat related one that we did. So, for example, we ran all combinations of R values, window U values, glazing ratios, and a couple of HVAC parameters that we were interested in studying for an office here. And particularly, this was just a perimeter zone, but we were looking at the sensitivity. So the slope of these results is how much of an impact each of these parameters has over that entire design space of things that you can look at. So for these offices here, we could see, like, if we're going to try and put our money on one strategy, probably increasing the wall R value beyond the code minimum of what you see here really isn't going to give us much bang for our buck. We'd be much better off investing that in better windows or more tightly insulated windows. And certainly, if we could stop, have a lower glazing ratio from the start, that would be way more impactful than either of those two together. And again, things like that's even more impactful than heat recovery in this case, or more efficient heat recovery. But probably the most biggest impact in this case was in the difference between a hydronic versus an all-air HVAC system. And so we do this a lot of times for projects in my office that we'll do, so that's an office model. For classrooms, it's a different design space and a different type of sensitivity analysis. For laboratories or wet labs, it's again, a totally different design space because things start to become really HVAC dependent. So yes, these types of sensitivity studies can be done once you're working within a parametric interface like Rhino Grasshopper. So hopefully that answered your question, and I can pass it off back to, let me see.
Yeah, I'll do it. All right, let's do maybe one or two more questions, and then we'll end the webinar. So the next one is, and this may be for Michal, because this, I think, is in reference to Spider. Do the surfaces represent the inner or outer part of the walls and floors?
So as per gbXML schema, at the moment, the walls from Revit BIM are taking as a center line. So at the moment, they are taking only as a center line whatever you drawn in Revit, if is the question regarding the Revit. So obviously if you build your own model using Rhino or Grasshopper, you just already have the center line. But at the moment when you're exporting from Revit, it is always taking as a center line. Yeah.
Okay, thanks, Michal. All right. Here's a question. I have a walk-in basement. Some of the wall contacts the soil, some are exposed. Revit has some difficulties with exporting such a model. Can I fix it with the Spider interface?
Exactly, you can. Maybe I'm wondering if I should show quickly, because I think maybe I didn't show it very well. Maybe I can show where we can actually change all the types. We have full control over this. So again, I'm showing my screen, and let me know if you can see. So if we select any surface, let's select this one. You see at the moment it's at the ground wall, but I can actually select this one and change this exterior wall to underground wall. And you just click update, and you can see even color changing. So this is exactly what we have our tool for. We can, for each of the elements, we can change the type, we can change the CAD object ID, and we can change adjacency. So if I know this is wrong space, we can actually change to different space and click update as I did. So we can modify exactly this tool for all the properties of all the models. We can actually change the type and so on. But I completely agree with you, especially if you have the profile. Revit will not correctly assign which part is underground, which is not. And this is exactly what we have this tool for.
Okay, great. Thanks, Michal.
Yeah, no problem.
All right. One more question. Is this tool, and I'm assuming Spider, is it compatible with FreeCAD or other open source modeling software? So I'm not sure if anyone can answer that.
I think as long as someone produced gbXML, we can load any file, so it's irrespective of. Obviously, we have some kind of CAD object ID, which is like set up to view in Revit, but it's not limited to any gbXML for any software.
Okay.
Add that
here's a question.
Oh.
Yeah, go ahead,
That's
Chris.
okay. We're for all the other insects that are plugging into the CAD interfaces right now, we're in the process of rewriting all of the libraries of those insects to be standalone Python and cross-platform. And in that case, we're aiming to support multiple interfaces for those, including things like Blender or FreeCAD. That we're trying to make it much easier for people to port it over to other CAD interfaces. So I think that seemed useful to answering that question as well. So we can go to the next one.
Okay. Actually, we're going to end now since it is after 11 Pacific time here. So like I said, any other questions that were not answered, we do have record of them, and we will, send those questions to the various panelists and try to get those answered and post them on the gbXML website. And also, I will be posting a recording of this webinar on our website. So that is all. Thank you very much to everyone who has attended. I think it's a great webinar, and I think we could do almost a follow-up to this since there is so much to show. So thank you all, and have a great day.
Thank you, Stephen.
Yeah, thank you very much.
Thank you. Have a good one.